Hello everyone. I've had a couple of emails throughout the day, but I'm having issues at home with emails uploading videos. So I am now in my office trying to record some videos for y'all. So the next question that I'd like to go over is the very first one here, where we have this exponential function, and we're asked to plot it on a semi-log scale graph. So I think the book is the best way to do that. So a semi-log graph is one where instead of having x and y as your axes, so we're used to seeing, say, x here and then f of x here, we are going to shift it so that way we have some logarithmic scale that we're dealing with here. And what that'll do, as you can see from here, is it'll take a function that was originally an exponential curve, right? So when you graph it, you kind of see that exponential growth or decay curve, and it'll change it into a linear model with it, because we are canceling out the exponential growth with its logarithm, so that way we can see how it's spaced out. Okay, so what that looks like essentially is you have your exponential function like this, and then you're going to take a log base of each side. So in this case, if we just have something that isn't continuous, then we'll just take a base logarithm of both sides, and you can see we're going to be able to use some logarithmic properties which we're going to utilize here. So for example, I'll go ahead and use this question. So in this case, I have some y equals 6 times 1.4 to the x. So I'll go ahead and open it up here. So we have some y equals some 6 times 1.4 to the x, right? So that is my function here, and I need to change this to to a logarithm. So the problem with this, right, is as we're moving along with these exponentials, it's hard to graph these initially, trying to get a good scale of it. So what we're going to do is we are going to shift it by taking a logarithm of both sides like this, and then we are going to simplify this down. Okay, so we now have our outputs being this log base y, but we need to simplify this part of it. And when we do, what I want you to notice is the way these exponential models are set up, this ab to the x, is we have a times b to the x. So in this case, it's 6 times 1.4 to the x. Well, within a logarithm, we have a logarithmic property which says when you're multiplying two things, that is the same as switching them, so that way we can add those two to the same log base. So in this case, I have a common logarithm, so log base 10 of 6 times 1.4 to the x is the same as log of 6 plus log of 1.4 to the x. So that's that first piece of it here, right? So this right here is something that I'm going to continue to manipulate. So having an exponent out here, there's another logarithmic property which says you can move that to the very front of our logarithm. So having that log base up there is the same as moving it like this. And when we're setting this up, what you can see here is we have something very similar to log of y equals some mx plus b. And this is what we're ultimately driving at, that when you use these semi-log graphs, which is really just a fancy way of saying the way you're counting on one of your axes is logarithmic. So in this case, we're counting with log 10. So every 10 units we have, we're gonna count it as 1 instead. What that does is it makes it so that way it creates, here I'll show you, it creates a linear plane off of it. Okay, so so when we shift it over, it essentially makes it easier for us to see it. It moves the scale of how we're counting. Okay, so so that way it's something that's a little easier to sort it out. So for example here, when I'm looking at it, it's really hard to say, well, where exactly is our graph when we have x is 5, right? So if we were to sort that and we wanted to figure here, it's up at 32. But the further I go with it, right, like it's hard already to envision this at some finite value like 5. Well, what if it's, say, something like 50, right? So the scale of this is so big that we need a more appropriate way to count this by. And if I change it this way, notice that what my m becomes, what my slope is this log of 1.4, and my y-intercept becomes log of 6, like that. Okay, so it makes it so ultimately we can create a line off of this, right? So I don't know. I know that Desmos has difficulty counting these things out, so we will see what it looks like. But it makes it so that way how we're counting here isn't just on an integer scale this way. It makes it so this is now counting by log base 10. Okay, so every unit we move up here, so here we're at 0.778. If I go to 1.778, it means that we've actually moved up 10 units that way. So instead of like changing how we're counting this way, we are converting the entire equation into a way that makes it a little easier to sort it out. What does that mean in terms of the question, right? So if we go back to this thing, what is this really looking for? Well, it wants to know what these pieces are, right? So, so if I convert this over to some linear model, well, then my slope would have to be counting by log of 1.4, right? Like that's how I'm moving up compared to over. And my starting piece here, this log of 6, is where I'm going to start out at, right? So again, it is fairly complicated. We originally, so if you're sitting there thinking, well, when would I ever use this thing? We actually used this. We attempted to use this as a way to give a better way to envision exponential growth, like say with COVID cases that were spreading throughout the world. It was difficult to communicate, well, how quickly is this thing spreading, right? Initially, the panic was just like, oh, that it's going at an exponential rate, therefore I have no concept of how it's really moving. Well, the way we were trying to communicate that for a little while was using logarithmic scales. So, but that was too difficult simply because the population was too ignorant to actually deal with it. And I don't mean to say that in some pompous way. I mean to say that it's easier to count by logarithms when you're dealing with something that is growing exponentially. It makes it so you can then get a better use of it. Okay, so that's essentially what it is. But now I'm self-conscious. I feel like I'm being pompous with it. But yeah, that is the most recent application I can think of where these semi-log graphs come into play. Yeah, so hopefully this will be able to translate. My hope is to take these videos and put them into Canvas, as well as hopefully attach them over. Several of you are emailing me, letting me know that you're not able to access those files, so I'm hoping that one way or another we'll be able to get sorted with this. All right, again, I hope you're all well, and I hope you get to see this. All right, bye-bye.